Okay, here we go. Perfect. Hello everyone. How's everyone doing today? Hello Tarun, hello Harsh, hello Enrico. Where's everybody joining from today? Welcome, Anantu. We are so excited for today. Okay, we got someone from California. I'm here from California. Scotland, Virginia. Hey Mark. Man, I'm so excited, guys. You guys have no idea how many people signed up for this course. It's crazy. Okay, we have someone from Bangalore, another person from India. Okay, oh, hi Shalini. More from California. Nice. Paris, London. Welcome. Welcome, guys. Is everyone ready to get started? Hey, Lucky from London. Good to see you. Javier from Peru. Welcome on board. Cool. We have a big, a good size group. Anyone who's joined in the Google Meet, you have to go to the link in your email. There's a different link. We're not going to be using the Google Meet. So if you're in the Google Meet, you are in the wrong place. Okay? Yes. Go to the YouTube live. Okay, great. Perfect. Good. Yes, and this will be recorded. Okay, Los Angeles. Welcome, everyone. Good. Cool. All right. So happy to see everyone. This is exciting. Awesome. Okay, welcome everyone to the AI Agent Camp. We are getting started right now, and I am here with a little help from behind the scenes with some people who you are about to meet in just a minute. Hey Curious Coder, welcome. Welcome Enrico from Dubai. Welcome Tarun from India. And we are going to be, oh hey Michael from Ethiopia. And yeah, welcome to AI Agent Camp. So this is actually the second course this is the second course that I've hosted. It's part of something called AI Foundations, and if you want to learn more, you can go to aifoundations.school. And the first course, hey Dashnik, Dashnik from Cameroon, and the first course we did an introduction to machine learning and neural networks, and that was super fun, and that kind of inspired me, and yeah, now we're doing something even bigger. So this is AI Agent Camp, and you're going to be learning today how to make AI agents. We're going to be using open source models, open source LLMs, and Python. And that's it. So here's the curriculum. These are the lessons. It's a short course. It's going to take you about 5 hours. You have to be comfortable with Python. Is everyone here comfortable with Python? I hope y'all are comfortable with Python because we're going to be using Python a lot. Okay? The first sort of pre-lesson that we did was on LLM deployment. And okay, perfect. We got a ton of experienced Python developers here. I'm going to need your help in a few minutes while we make the first agent. So, awesome. So the first pre-lesson that we did was on LLM deployment. We learned how to set up Llama locally using OLlama and how to write a basic script to interact with OLlama and to call it. So that was sort of like a pre-introductory lesson. You can find it here on this channel, and go ahead and watch it later if you haven't already. You don't need to watch it before today's lesson. All you need is a computer that you can sign into Colab and to be able to follow along. So today we are going to be building ReAct agents, and as you cannot tell from the way it's written, we are not talking about JavaScript when we are talking about ReAct. That is just unfortunate way that ReAct agents was named, but we will be it stands for what does it stand for? ReAct agent. It stands for reasoning in action, right? Reasoning in action. So basically, that is a type of agent, and we're going to be Thanks, Daniel. Thanks, Michael. Get a little nervous up here. So that's for reasoning and action, and this is just a basic agent that we're going to be building from scratch. The next lesson we're going to be covering JSON agents. So that's going to be more what's called today tool use or tool calling. And basically, it's just an evolution of the same thing, but these agents are, the LLMs that they're working on are fine-tuned to provide more structured kind of outputs. Then following that, we are going to be using code execution agents. We're going to be learning how to make agents that operate based off of writing code and running that code directly rather than choosing between a number of tools. Then we're going to learn how to make agents that can control a web browser. So agents that can use the web browser as a type of tool to browse the web. And then finally, we're going to be learning how to make agents that can control an entire computer operating system by moving the mouse and typing the keyboard. This is the newest, craziest type of agent, and they don't work very well, but who knows how well they're going to work in a year from now. Maybe pretty well. So here's an example of an agent that I made for my work. This is a computer use agent, and it is tasked with the prompt to change the desktop background on the computer within the operating system that it is controlling. Now, as you can see, it is actually like moving the mouse, and it has computer vision abilities. So this was the hardest project that I've ever done before. Maybe one of the most challenging things that I've ever worked on, and it's what inspired me to start this course. So you can kind of get excited for something like this towards the end of the course. And another project that I have worked on, which has been amazing alongside a number of other awesome open source contributors, is sort of like a cursor-like editor that runs in your web browser. By the way, these are both totally open source. The source code is available on GitHub. And while this right now just uses LLM code generation, we are very soon going to be able to generate code projects using an agent code generation loop, which will be able to create the whole project on its own. So these are two really fun agent projects, just kind of example of the kind of stuff you can make with the stuff that you build, with the stuff that we're learning starting today. So in this course, we're not going to be talking about frameworks. There's a lot out there. As I was building my computer use agent, I tried a lot of different things. I experimented with different frameworks, different architectures of agents, and when I finally felt like I understood what I was doing was when I just went back to the basics. I read up on how the models work, and I just rewrote the code in vanilla Python. And that's what we're going to be doing here. Everyone here will be able to write their own LLM reasoning agent framework by the end of this course. And as you're going to see, as I was kind of surprised to find out, it's not that hard to do. We can do in actually 100 or 200 lines of code a basic agent framework in Python. Cool. So that's from me, and helping me with this course, I have two amazing guys here, and so I'm going to introduce them to you now. They're going to be the TAs. So when you have questions, you can reach out to the email that invited you to this course, and one of us three will get back to you. So, and they're here right now behind the scenes and in the chat. So let me just introduce them to you. All right, so here is Burhan. Hello, Burhan. Go ahead and introduce.
Hey guys, it's me, Burhan. I'm a CS undergrad, and yeah, we're building AI agents today.
Thanks, Burhan. Where are you from?
I'm from Pakistan, and I'm currently in my sophomore year of my college.
Nice. And how did we meet?
Yeah, we met through a hackathon, and we built a project together.
Yeah, I'm an
That's
online GPT.
GPT
What was it?
4.0.
4 up, 4 up. Yeah, I was gonna
Yep,
say. Yeah, cool. All right, nice. Thanks a lot, Burhan.
of course.
Always a pleasure building with you. And our second TA here is Jonathan. Hey, Jonathan, please just give a quick intro.
Hey guys, hey James. So I'm Jonathan, and I'm a software engineer, and I love all things AI. I'm currently a master's student, and I'm studying artificial intelligence in England. Yeah, um, go on. That's it.
Great. Thanks, Jonathan. Where do you live in England?
In Leicester City.
In Leicester City. Cool. So we're covering all the, and I'm in San Francisco, so we're covering all the time zones between
Sure,
us.
sure.
So probably 24 hours a day you should be able to get help when you need it.
Sure.
Great. Okay, thanks, Jonathan. So with that said, now we're actually ready to get started. So I'm going to be coding live with you all. I'm a pretty experienced coder, but unfortunately I make mistakes all the time. So I really need everyone here to help me out, to keep your eyes on my code, and to help me as we kind of debug, go along, and figure out how this agent thing works. So I'm gonna be working in a Colab notebook. I assume most people here have used Colab, since you are familiar with Python, right? Cool. So I'm actually going to, I'm going to call this React Agent Lesson, and I'm going to share this notebook with everybody here in the chat. So that way, as we are going along, you guys cannot edit this, but you can actually follow along with the code. I really encourage you to create another Colab notebook, because at the end of it, we're going to be customizing, and you're going to make your own agent with its own tools. So definitely make a new notebook, and also follow along with mine as we are coding. Cool. All right. Is everyone ready to help me out here? Good. Good. So first thing that we need to do to make an agent is, well, we're gonna need some kind of LLM connection, and I mentioned in the email before this class to set up an Open Router account. Now, Open Router is one of many sites. Here, I'll go now to the website. It's one of many sites where you can try various you can run various LLMs for free. Well, some of them are for free. So here, if I change this pricing down all the way to free, we don't want to use Quen today, but we want to use Llama. So go ahead and create a free account here at openrouter.ai. And yeah, you're actually going to be able to start running Llama without any credit card. And if you watched the last video, you saw how to set up Llama locally on your own machine. Now you can do that. You can actually do this whole thing with locally running Llama. I'm just going to be using Open Router, and I recommend you do too, because it's much easier to connect to from Colab. So let's have a look at the models here. Today we're going to be using Llama 3.2 9dB Vision Instruct. We just want to get that 9dB parameters for the the power of it. It's one of the best models out there that's open source and can reason. Cool. And in order to run this from our Python code, we're going to be using the API they provide. Now, the API that they provide here is the same as the OpenAI chat completions API. So if I just look up on Google for the OpenAI chat completions API, and I go to Python here, I get a pretty good example of how to call the OpenAI API using the OpenAI package. Now, if I search for Open Router chat API, I get something really similar. And here's what's great. Most of these online providers, they're now using the OpenAI format. So that means that this code, and whatever other provider we want to use, it's going to be almost exact. It's going to be the exact same code, except for different base URL and different API key. So let's just copy. Yeah, let's look at this. This is TypeScript. I don't want this. I want Python, right? So let's copy the Python code, and let's paste that into our Colab notebook. Now we need to have an API key, even though it's free. I have all my API keys already set up here in Colab. But if you wanted to add it, all you have to do is you'll go to, so you'll be here in Open Router. On the right side menu, you can't see it, but there's something that says keys. So you click on that, and here's my API key, and I can create a new one. And once I fill this out, I'll get this key. And so then once I have that, I'm going to go back to my Colab notebook. I'm going to click Add New Secret, and I'm going to type Open Router API key, just like this. And then I'm going to put in the API key here. Now I've already done that. So all I need to do to get this to work is to copy this little snippet here from Google Colab and paste it up at the top. And here I'm going to take this this method that lets me to get the Open Router API key, and I'm going to paste it. I'm going to paste it here. For this API, there's some limit of tokens per hour or tokens per day, but I wouldn't worry about it right now. It's pretty generous, so I think you should be fine for this workshop. And then I'm going to change secret name to Open Router API key, and that's it. So this part that says optional, that's just for tracking statistics. So I'm going to delete that, and I'm going to run the code. Is everyone following along okay so far? I mean, if you're following, thanks Burhan. So if you're following along here, oh, by the way, it's going to ask me to give access to the API key. Perfect. So if you're following, run it again. So if you're following along here and you're looking at my Jupyter my Colab notebook that I sent you, then you might have to refresh the page sometimes to get my updates, by the way. Cool. And someone said, Mark said, but you're not accessing Llama yet, right? No, I'm not. Look, see, it came with GPT 3.5 in there. So to get the other model, I'm just gonna go over to this model catalog that I just had open here, and I'm gonna find the model I want, which is MetaLlama free, and I'm gonna click here to copy, and I'm gonna paste that in here. All right. Now we'll run it again, and actually let's compare. Run it again here. So just by changing this, we have access to hundreds of models, paid, and maybe 10 or so. Yeah, exactly, Turin. So here we've just changed the model. Cool. And so now we're getting this really wordy answer from Llama. Perfect. So I can delete this one. And this is the response from Llama. Cool. Now we don't just want to call an LLM today. That would be some lesson. So what we're going to do now is we're going to talk about reasoning. We want the LLM to be able to do things. I mean, that's what an agent is. It's an LLM that can do things, right? So here we have Enrico. Once I save it, I think it will refresh for you. So here we have a prompt, right? So we can change this. We can change this prompt to whatever we want, right? And well, we wanted to be able to make a choice. The idea is just that we're asking the LLM what to do, and we're giving it some different buttons, and it's going to make a choice. So I don't know. Let's just do an example here. We're gonna make this into a longer prompt string here, and I'm gonna say, I want to open a present. Okay, and I'm going to have it help me to. I'm gonna have it help me to do that. Now we want to kind of separate out the prompts that are more to do with like programming the LLM versus what the user has entered. So I'm gonna add a system prompt here. I'm gonna just copy and paste that, and I'm gonna call this system. Now, a system prompt is really, it's supposed to be a stronger prompt. It's supposed to be be able to enforce the LLM better. In practice, I don't know how well that works, but let's say something like this. Let's say you have access to the following tools. All right. Now remember, we're talking about opening things, so let's give it some tools for that. You know, let's say you have a knife. Okay. Let's say you have maybe a machete. Maybe you have a chainsaw. Okay. And let's say a rubber band. Okay. Now, all we're trying to do is use this LLM in a way that it can make decisions and it can actually do things, right? So I'm gonna try and force its output to be in a way that will be useful to us to make an agent. So I will say use the following format. This is all just prompt engineering so far, and here we're getting some nice auto completion from Colab. So actually, yeah, I'll just use this. This looks pretty good. So if we ask it to respond in this format, then that also means that the question is the user prompt here. This is the way that it's defined it. I can put that here as well, because the input question that it must answer, that's the input from the user. Now this part, this thought, let's take that away for a second, and let's take away the action input for a second. So let's see if we can get an LLM just to choose which tool is going to be the best for this problem of opening the present. Okay, it's a knife. I would say that does that checks out, right? Now what's this output format that we're actually getting from the provider? Here it's a chat completion message. Okay, so let's say it chooses the knife, right? Then it's chosen to do an action. Then in order for it to learn, in order to get information from the environment, there needs to be a result. There needs to be a result of that action, and it needs to be able to learn from that. So let's say, so in that case, we need to actually create a sort of a history. You know, we need to sort of create like a chat history. So the way that I'm going to do that is I'm actually going to take this, and instead of passing it directly, I'm going to put this into a variable, chat history. All right, and so that should do the same thing when I run it again. But if I would want to add this action to the history afterwards, it would probably be something like this. Let's run this again, and then let's do chat history dot extend, because the history so far, if we look at the history after this, it's just what we put in, right? So we want to actually be creating a history here so this agent can learn. So the way that I'm going to do that is I'm going to be extending it, and I'm going to be using the same format, right? So role, and then whatever the agent does is the assistant role, and this is just the format used by that was created initially by OpenAI, but is now kind of standard for all APIs. We have the system, the user, and the assistant. The system is the programmer, the user is the prompts coming from the user, and the assistant is whatever the agent or LLM is saying. So we can actually just take this this response text, and we can just pass that back in. That's just storing that. That's just storing that content here. Just adding it to the history. So here, I'll do that again. And now for here, we also want to give it an observation. So okay, let's run this, and let's also add an observation. Now here we're going to be the world for the agent. We're going to kind of mess with it a little. So I'm gonna say we're gonna role play a little bit. So I'm gonna say user, and then I'm going to say the observation is the knife did not work. What tools do we have here? We have a chainsaw, good. So I'll say a tree has fallen down between you and the present. Okay, so let's run this and look at what chat history we have here. Okay, we have a history here. So the system prompt, and then the user says, I want to use a knife. I want to use a present. The agent said, action, knife. Okay, so this is its way of saying, I'm using the knife. And here I should actually change this to say observation, right? In order to be clear. So let me run that again. And this one. Cool. So now the observation, the knife did not work, a tree has fallen down. So this is kind of how an agent interacts with the environment. So let's run the agent again. Let's run the LLM again and see if it can learn. See if it can learn, and what is it going to do this time? Okay, so actually I'm just going to actually copy this exact same thing, and then this is the first time I've done this example. So we've taken the whole chat history from everything that's happened, and we run that again. And here we get action chainsaw. All right. So guys, we are so close. We've been working on this for just a few minutes, and we're so close to actually having something that can kind of learn, right? An LLM, it just takes texts, text input and text output, but through this special prompt that we've made, we have forced it to use the following format, which is the question, the question and the action format. And some people have figured out that if you get it to talk more, it tends to do better, right? And so that's why they also put in this this thought step that says you should always think about what you do. Okay, this is just prompt engineering, and it's also called chain of thought. So the idea is that if we add that in, then it will be smarter. So let's just run it again. Of course, it'll do the same thing because it's already given the correct answer. So here we have now. So we'll run it again. And we see here now it's added a thought step. Okay, I need to carefully remove the wrapping without damaging the gift. The wrapping is likely held in place with tape or tightly. And now it's decided to use the rubber band. Wow, okay, That's so interesting. The wrapping is likely held in place with tape. Okay, cool. So in this case, it actually decided to use the rubber band. It seems like the chain of thought has led it to come to some kind of conclusion. And you'll find that with agents that they're totally unpredictable, the kinds of conclusions that they make sometime. And as much as you play around with them, you'll sometimes get really you'll get really unexpected results sometimes. So that's now here I would want to say actually something like the rubber band did not work, and then I would do this, and then we'd run it again. But I think you all are getting the point here, right? Yeah, llama thinking like Socrates. So, are you all ready to make an agent out of this? I think you can see where this is going, right? So we have our code that calls the LLM here, and we have kind of figured out how to get the LLM to make a choice, to pick an action, and then we tell something back to it, and then it takes that new info, and then it makes a new choice. Now, the final thing that we probably want to do is, well, imagine we're going to now run this in a loop, right? Well, the final thing that we're going to want to do is we're going to probably want to have it be able to do this any number of times until it has succeeded, right? So let's look at the prompt. Here, we told it to use the following format, right? That means that it will always do this, even if the present is already opened, right? If we just run the LLM call again, it's gonna keep sorry, it's gonna keep giving thoughts and actions. So one thing we could do is we could say if we could say if you're finished, if you want to make an action, respond in this format. Otherwise, if you're finished, just say final answer, the answer to the original input question. Hey Brian, good to see you. One of my students from data analytics. So this is the this is a way that we could do that. You know, it's basically really the same as adding another action, and the action would just be finish. You know, so essentially what we're trying to do here is let me just make a quick diagram because I think it will help. Is we have here the LLM, and then we're starting here. We pass some stuff to the LLM, and then based off of the output, we make a decision, and that decision is, oops, here, are we finished? And then here comes out of course, the LLM response. Here comes the chat history. We want to decide if we're finished or we're not finished. If we're not finished, we're gonna go back, right? And so, what is it that we're checking here? Oh, did the LLM take an action, right? Yeah, exactly. So, so we have so far we've done one of these loops manually, right? And as I've just described, by just kind of tweaking the prompt, we can get it to say if it's finished or not, right? Now this would be one way to do it. Now there's a pretty cool trick, and actually I didn't learn about this trick until I started messing around with ReAct agents. And that trick is actually to to not give it these two different options of being finished or not. The trick is like this. You can actually say, use the following format, and then here, after the action, so you can actually say observation, the result of the action, and then here, just say the thought, action, observation can repeat any number of times, and then the final answer. And sometimes they put thought, I now know the final answer. Okay, so none of this is fixed. None of this is canon. It's really if this works, something else will also work. Many ways to do this. But once I saw this prompt, I was a little bit confused actually, because I was wondering how could this work. Do you guys see what the problem with this is? Burhan or Jonathan, do you guys see why I was kind of stumped by how something like this would work? Yeah. So I was stumped because when you run this, here, let's run it. Let's see, we didn't get a response text. We didn't get a response text back this time. Let's run it again. Did I run out of credits? Okay, we're good. Because when you run this, you get hallucinations, right? You get here, the knife has successfully cut through the wrapping paper, but it's having some difficulty. Okay, let's try the machete. Oh, that's way too strong. Okay, the machete's too much. Let's go back to the knife. So this has hallucinated not just the actions, but also the observations. So I was looking at this when I first found this piece of code, and I was like, well, this is much cleaner prompt, but yeah, how does it work? And then I thought, okay, well, I guess what we could do is we could just ignore everything after the first action, right? We could just delete this, and then we could continue on the way we were doing, because we wanted to be able, we want the code to decide what the response of the tools is. The LLM doesn't get to decide the output of its actions, then there's no point, right? So I thought, oh, I can just find this and I can delete it. But then there's another trick which you can do, and you can actually, here in the API, you can actually add a stop token here, and that defines a string where the LLM will actually stop. Now we already know where it's going to start hallucinating. It's going to start hallucinating after the action. Main thing here is once the LLM decides on an action, then we need to run. We need to start running the tools, right? So we're going to be doing that here. We're going to run the tool, and then the result of the tool gets passed back to the LLM, right? So if we put this stop token here, let's see what happens. Ah, perfect. Okay, so this is really clever, because with this one prompt, we have handled both cases. The case where it takes another observation, or the case where it's finished. So yeah, that's it. Now we just need to wrap this up in a nice Python function, so that we can do this with some actual tools that are useful, right? So let's first fix these kind of tools because we've given it, just some imaginary tools. Let's use something that's a little bit more useful for an AI agent. Let's give it a calculator, okay? And let's take out this here, this prompt here, and let's turn this into an F string here, and let's put this into a variable, the user prompt. Okay, so the user prompt is going to be something like calculate the square root of 144, right? And we're going to give you a calculator, give the agent a calculator, and we can give it more tools as well, of course. We know. And yeah, let's just go with that. Oh wait, it also needs to have an input, right? I should fix this, and then it needs to have an action input. Okay. So we will run this now with the calculator example. Okay. Now this is kind of a funny format. How are we going to actually calculate this? Well, fortunately in Python there's actually a library for that, and it's called SymPy. So I'm gonna copy this in because this is not part of the understanding of agents. This is a function here called calculator, and I'll prove that it works. I'll just run 1 times 2 times 3 times 4 times 5, and there we go. Okay, we have a little calculator here. We would ideally like it to use the right syntax here, right? So I'm going to say here for the calculator, I'm just going to say use this when you want to do math. Use SymPy expressions. Okay. For example, 2 plus 2. Cool. Let's see how that works. How's everyone doing so far? Is anyone able to create their own agent? Cool. All right, this is much better. So now if we would actually take this and put it back into our calculator, then I have gotten, oh, okay, here use SymPy expressions. So that's not exactly correct. Let's see if it always does that. Okay, perfect. We have some people that are keeping up with the code as well. If you fall behind and you want to copy and paste my codes, this is correct. It looks like it just made a mistake, the LLM. If you fall behind, you want to copy and paste my code, I won't be angry. So if we would take this and paste it here, then we get the response. Cool. All right. So we're just doing this by copying and pasting. Now there's a great way to not do that. We could do this in a loop, right? So let's do this. Here we've already defined the user prompt. We've defined the chat history here. Let's make a little loop. So we'll say while true, call the LLM. All right. So this will create a infinite loop, which will just keep calling the LLM with the chat history. Now, somehow here we want to do what we just did over in my diagram here. We want to see, did the LLM take an action, right? And then we want to if the LLM took an action. And took action. This is pseudocode. Then go again, get the result, and go again. Else, we want to stop. We want to stop the loop, right? We want to stop the loop, and we want to, just see the results. Let's also print this every time we call the LLM, and when we get the results, which would be the observation, we are going to pass that back to the chat history here. .extend, we're going to extend it the same way, actually the exact same way that we did before, right? Just like this. Okay. Right? So so then the question is, and of course this observation is going to be this observation here is going to be the action result, right? So how do we figure out whether or not it took an action? Well, this is all just strings, right? So we can use we can use different kind of string functions. You could do a search, a string search. Let's use a regular expression to do this. So I'm just going to write a function called extract action and input from any text, and it's just going to be okay. Colab is giving me some that actually looks okay, but I prefer to use regular expressions, and we're gonna search. See this here? We're going to search for the action within the text response and the action inputs, okay? And this is good what it's done, but it will return an error if there's no action. So what we really want to do is to do like this. If action, else none. So that way we get a graceful none if this text was not found, right? And that's the case where we're going to end the agent. So what this function does is it looks at the response from the LLM and it answers this question: did the LLM take an action? And then, let's give it a shot actually. So do we have this here, this response text here, right? So init, okay, init, input, okay. Let me put this separately up here, okay, here, and let's test it, okay. Let's just test it like this. It's nice to have some test cases. Okay, great. So here, of course, import read, okay. Yeah, that works pretty well, right? Okay, so now, sure. Yeah, well, sure, Burhan. Was something unclear, do you think? Okay. So what this code is doing is it's just doing a text search through this string to look for this, right? To look for this and for this, and that's so we decide whether the LLM has decided to make an action or not to make an action. Yeah, dash Nick. You will be a little bit lost if you're not a Python guy. However, you can always take this code we'll show that we're sharing the code with everyone as we go along, and you can take this code and you can have a closer look at it later. So here you go. So this is not one of the nicest lines of Python code here, definitely. It's simple what it does, but it's not nice to look at. So we're gonna use this in this loop here, right? We want to do something like this. We want to say action input equals here. So take the output of the LLM call. Here it's saying if action is none, break. Yeah, that's basically the same thing we're doing here. But here I can say if action, and let's make sure that the action is, just in case it decides to use a different tool, because we do want to be able to check different tools. Let's make sure it's the calculator. Yeah, for sure. Keep going along, coding along, and see what you can get to. So then we gotta get the result. Okay, so action result equals calculator. What was it? Action input, right? And then yeah, we pass this back into the chat history, right? Everything that the LLM just did, we pass that back. And then we also pass back the observation. And then we get that's left over, right? And then when this is finished, then that should be it. I've made a mistake here. We want to add, here, this should be a separate variable. Okay, so that's cool. Okay, let's see if we can run this whole block of code now. Mm-hmm. Yeah. Burhan has asked if I could just kind of go over the flow again. So we have this. Let me run it. Let me just go through it here, right? We start here. We take a chat history, which is something very simple. It's something like just like question, calculate the square root of 144, right? And then we pass that to the LM along with the instructions. So we start here, and then we have this, right? And then and then we go to this step, bring this to the LLM, and the LLM gives out a response, which is something like action calculator, action input, square root squirt 144. Let me move this over, as you can see it. Yeah. So, this is the chat history as we're going along, and I would even try and make these. I'll even make these different colors to make it easier to see. So then we get here, and we get here with the LLM response. Then we get to here, and we're analyzing the last bit that just got added. We need to decide: are we finished? Or are we not finished? Well, it gave an action and an action input, so we're not finished. So then we go to here, and then we run the tool and we put in the observation, and that will be is it 12? I think it's 12, right? We put in something like that, and then after the observation has been run, after this, so once we just do that, we go back here. And now the LLM has to decide what to do. It can do this again, although let's say the observation is something like, let's say it does do something weird, then the observation can be like error, and then maybe it would do calculator again, and then it would fix it. That's that's a possibility. Or in this case, it did do the right thing. So it's just going to, instead of saying action input, it's just going to say something like thought. Now you can have a thought here as well. These are just reasoning, blah blah blah. Thought. I have the answer, and then the LLM is just going to copy. They're literally just going to copy that from there. So that's kind of, and then we're here, and then we're here, and then we see that a new action didn't get added. So then we go over to here. How's that? So that if you read through this Python code, I could walk through this Python code again, but I think this is really the key. This is how I understand it. Some visualization like that. So so that's this. And now let's print. Sorry, I meant to print the response text each time. Now let's run it. Let's run that. All right, hey, and look at that. So exactly the example that I just gave here, where it actually gave the error. That's where it had the observation error. This one. That's exactly this first case that I gave. That's exactly what just happened. So if we look here, the agent's thinking, to get the square root of 144, I should use a calculator. And then it says, okay, calculator, that's my only option. And then it thinks that this is the right format to use. It's an LLM. It's very unpredictable. Who knows what it's going to say? I forgot to print here. Yeah, I forgot to print the response here, the result. So that would be more clear. But you'll see here actually, if we just print, if we printed the whole chat history, what you would see is you'd see actually an error coming out of the calculator. So let's run it again. And what you'd see is that error. It will see that error, and that's why it said this. It said, "Oh, this is not working," and then I need to try it again with something different. Okay, so let's see if that works better. Oh, I only want to print this part. This is the only part I missed. The rest of it is actually fine here. And we'll see if we would just print this now. We can see that it worked the second time, so the error is already gone. Let's run it again and get the full history. So here we got the thought, action input, observation, everything we just went through. And let's run it again. And here we actually get it. This is actually an error on the LLM side, so that's not to do with us. It's something we could handle, but okay. And here it's stopped early. So for some reason, instead of, so you see there's all the different unpredictable cases that you have to test, and so here the action result, let's see, did it run it? Action result was let's see did it run? So here's the action input. Okay, and then let's check the chat history. Oh, answer. We're not, I don't think I've printed everything here because I've missed something here because here, oh no, it has stopped, it has actually stopped early. So this case here, f action equals calculator. Harsh says strip the action and action result when extra. Oh, okay. I think Harsh just caught it. Thanks. This is why I need you guys. So I think what happened is I think he just caught a bug here, which is that here, here. Oops, that's not what I want to do. I want to do this. There's a space. This time there was a space after the calculator. So he's saying to strip to strip that. And so I think in Python we just do we can add that. This is just a minor little bug fix up here, but we could do something like strip, right? Is that how it works in Python? I think so, right? No. Oh, here, like this. Perfect. Okay. Great. So I know we've been hustling a bit, guys, but I wanted to get everything done after an hour for you all, to show you that you can make an agent just on your own, not even really understanding all of the theory behind it. It's rather straightforward, and it's rather common sense. We just did this by asking an LLM to make a choice, and just by building up logical steps from there. Now, I had a whole bunch more that I wanted to show. I've made a lot of fun, cool agents just based off of this code that I have right here, and I'm sure you all can too. So what we're gonna do now is I'm just gonna ask if anyone has any questions. I'm gonna go through a few questions, and then I will leave it up to you all to take this code that we've written and then to add your own tools. Okay. What kind of tools do you think would work pretty well, Burhan? I'm bringing y'all back in.
Yeah, that was cool.
Yeah, did you like it?
Yep.
Yeah, awesome work. Yeah.
Yeah, was it? Did you were you able to follow along?
Yeah, the flowchart really helped.
Cool. So we're gonna ask all the students now to make their own agents, okay? And what I'm gonna do is I'm going to we're actually gonna be sending out a form via email, okay? Just in a few minutes after we end here, okay? And that form, here, let me pull it up. I lost it. That form looks just like this. Okay, it looks just like this. Okay, so this form is your homework submission. Okay, your email address, your Colab notebook, what tools did you add, and how well did your agent work? Okay, so what kind of tools could you add to something like this, Burhan?
A whole bunch of stuff. Like even if you just think about uh, running code through your terminal and then using that terminal response back to it, it could
Oh
actually
yeah.
debug stuff.
Oh yeah. That's an advanced one. Someone asking how could you make this kind of agent to modify files? yeah, you could do that with the Python file system, um, uh, with the FS library. What about you, Jonathan? What kind of tools do you think would be fun to add into
Um,
something like this?
Quite a lot. I would go for mostly research tools,
Yeah,
some to find information, on
yeah,
the internet. Yeah, and
yeah,
maybe a map too,
yeah,
so to find cheaper prices or anything.
yeah. Like a Google search. So there's actually this GitHub repository, which is called, here I'll show it here, which is called public APIs. You can search. There's like hundreds of APIs here. So for example, you have geocoding APIs, search, um, right? Gmail, anything here, you can integrate into your agent in just 4 or 5 lines of code, right? So those are some things. Jordan says like CSV files, text files.
You could use pandas, whole bunch of stuff.
Yeah, you could. Yeah, pandas to read a CSV.
I think
Um,
to answer his question, basically you
yep.
just have to give your agent tools, and with those tools, they can carry out action for you. The whole idea is to be able to give tools. So if you give it the CSV tool, it's going to carry out the action from you, take the solution, and then continue its reasoning.
Can you say that just a little bit closer to the mic one more time?
Oh,
It's a
okay.
little muffled.
I said the whole idea here is just to take the tools and give it to the agent to execute the tool and then return a response based on that reasoning. So whatever tool you're going to give to it is going to just take the tool, think through the action, and then give an output.
Exactly. So any tool you make is just a function that takes in a string and gives out a string. And ideally, it's something useful, and ideally, it's something that the LLM cannot already do, right? So math is a good example, but running a command is another example. Looking up a Google search is a great example. Um, Someone said a headlines finder would be cool. Um,
Someone
yeah.
also asked for the public API GitHub link.
Oh yeah.
Maybe you
You
could
can
share it.
literally just search public APIs, but here I'll throw it in here as well. Cool. All right. So yeah, take the whole point. Right. Yep. Yep. Great. So do you guys have some ideas? Good. So
Curious Coder said he wants to build a news headline finder.
yeah, yeah, that would work. That would work super well. There's if you go to like New York Times, if you search for New York Times API, you can find something that doesn't need an API key. Um, so so great. We will
Yeah.
be we will be sending that out. And here, let me just share the final slide. Here you go. Max, that would be Max's the Anthropic API cost. Oh yeah, yeah. We're using Llama Max, open source. And someone asked the next question. Someone asked when's the next session.
That's a really good
Um,
question.
Before that, let me just show this real quick. So this is gonna be so everyone send send in your oops. Let me fix that. Send in your agents, okay? And this is the I'm having so much trouble with the FMX. There you go. So send in send in your agents. If you don't if you're not signed up for the course, this is email address that you can email with how to get signed up. But if you got an email from us yesterday, then you're signed up, and you'll be getting a link to the Google form where you can submit your agent that you have developed. This should take 30 minutes to an hour. As you can see, we just did this whole thing in an hour. So the final question of when are we gonna do this again? Well, we have to do in the next session. We have to do JSON based or structured output based agents. So yeah, when do you think we should do this again? What do you think, Burhan? We can do it on Friday, or we can do it next week?
I think we'll leave that up to the chat because it does
Yeah,
depend the time they require to make the project. But
sure.
so that they could take time, we could move it to next week.
Yeah.
So I just want to answer some more few questions before we move on.
Sure.
Yeah, and I think one from Maxotix or so, and it says
Yeah.
if you want CSV returned, so you have to specify, right? Your function should be able to return the required output you want. And there's another question from Mark, which says, don't the set of tools you provide limit the question to which the agent can respond? So generally, you would want the agent to be able to do something and do it well, just like you have standard software engineering principles, which you have a single responsibility. There are cases where you have a set of agents, doing something together. So yes, the tools you provide actually constrains your ability of your agent. Yeah.
True.
Yeah. All right. So we're getting a lot of feedback in the chat. Some people say Friday. Some people say next week.
Most of them want it on Friday.
I'd say let's do Friday because, hey, if you're having trouble, if you can't make it, you can always watch the recording, over the weekend. And we want to, we want to allow the people that are making progress to keep going, so we could get through the whole course in, 2 weeks rather than 4 weeks. And then after that course, if it goes well, we can do it again. So, so let's keep up the pace. This is the recording right here. Of course, you can email us for help, and we will do our very best to help you with anything that is confusing. So try and make your agent, add your tools, send it to us by Friday, and then we're gonna go on. We're gonna go on to the next lesson. Sweet.
Sweet.
Thanks, everyone.
All right,
See you
bro.
on Friday.
Bye. Have a good one. Bye.